Hi team, today we're going to have a look at gametogenesis. This is the series of mitotic and meiotic divisions that occur in the gonads and ultimately end up with the production of producing gametes. Today's lesson is going to be very much specifically focusing on spermatogenesis, which is the process in which sperm cells are produced in the testes. So, take you back a little bit. Gametogenesis is, there are two types of it. One is oogenesis, which is the production of egg cells in the ovaries. And as I mentioned before, the spermatogenesis is the production of sperm cells in the testes. We will be comparing these two later on, and you will need to know the key differences between them. But we'll wait until we do one lesson on oogenesis first. Okay. So in the very beginning, male babies are born with spermatogonia. Spermatogonia is a fancy word for the germ cells or stem cells in the testes. These spermatogonia cells, they stay dormant until puberty when they are activated by hormones. So during that time of big change and massive big increases and changes and fluctuations in hormones during puberty, that's when these guys here become awakened, and they stay awakened for the rest of the male's life. I'm going to refer to the next bit of the process, crossing between these two diagrams because they very much correlate with each other. So you can imagine that these spermatogonia cells that sit inside of the testes that have been waiting and staying dormant for many years until puberty is hit, they're now awakened by these hormones. Once awakened, they then begin the process of mitosis. So if you think back and you remember what mitosis actually is, remember we have two processes of cell division and of replication. Mitosis is used for cells that have that are reproducing to form identical cells and that have 46 chromosomes in them. So the daughter cells will have 46 chromosomes, and we will end up with two identical sister cells. So what this means is that this spermatogonia stem cell is going to reproduce and create two spermatogonias. These two spermatogonias, you can have a look over here. So that's our spermatogonia. Then it reproduces in mitosis to get two identical spermatogonias. The two in this situation is representing two sets of chromosomes. So two sets of 23 chromosomes in the original spermatogonia. And then once the daughter cells are produced, again, two sets of chromosomes. So these guys here all have 46 chromosomes or 23 pairs of chromosomes. This is where it becomes quite interesting. So the process of mitosis is used purely to ensure that these stem cell numbers stay the same. So spermatogonia, that first one, divides and splits and creates two spermatogonias. Once there are two of them, one of them stays a spermatogonia, so it replaces this one back up here, and that's what this arrow shows. It replaces this one back up here, while the other one begins its formation of creating four sperm cells. So that spermatogonia, the second one, then begins the processes of meiosis. So it goes through and it begins meiosis 1. Remember, meiosis 1 is a very special part of the meiosis process, because it's in this process here that we have crossing over. So the DNA is actually traded and swapped between the chromosomes of the mum and that were passed down from its parents. So crossing over will occur, and they will divide and split. After meiosis 1, we have two haploid secondary spermatocytes. So they've gone from being spermatogonia into spermatocytes, but basically you just have two haploid cells. So you can see that the number's gone from 2n to 1n, so only one set of chromosomes in each one of them. After these guys here have gone through meiosis 1, they then finish off meiosis process with meiosis 2, where those haploid cells that have got DNA replicated are then pulled apart again to create four spermatid cells. Now, spermatid is just another way of saying immature spermatoza, and spermatoza is a fancier way of saying a sperm cell. So after this process of mitosis to create 2 sperm cells, meiosis to create 4 spermatids, we now have these spermatids, and we don't call them spermatoza or sperm for a very good reason. They don't have all the parts that are required for them to complete their mission as sperm cells. So in order to get this, they have to be, firstly, guarded and protected by Sertoli cells. Basically, these cells here nurture and protect the spermatids from the body. They take 6 weeks to mature completely, and I'm going to draw your attention over here to my diagram of what a mature sperm cell will look like. In order for a spermatid to be called a spermatoza or a sperm cell, they have to have developed and collected or created enzymes in the head of the sperm cell. So these enzymes dissolve the protective layer of the ova. If you think back to the Great Sperm Race, they show that the sperm cell, once it reaches the egg, the top of the head of it actually explodes, and it explodes so that the two can fuse together, and so that the DNA or the genetic information can be delivered to the egg cell. So these enzymes are really, really important. Without it, fertilization could not occur. So the enzymes have to be produced, and they have to be ready for it to ready for the chance and the opportunity to fertilize an egg. The haploid DNA, that's already there from the beginning, so that's nothing that needs to be developed. And the flagellum for propulsion. Without the flagellum for this cell, it cannot get to the egg. So that's what 6 weeks of development goes into in order for these spermatids to become 4 sperm cells. After they've become sperm cells, they are then moved into the testes tubules or the epididymis, where they await ejaculation. A key thing to note here, and it will stand out quite significantly when we have a look at oogenesis, is that these sperm cells, after they've been awakened from being dormant during puberty, they are created from stem cells, in a process in which those stem cells are constantly being replaced. So the replacing of these stem cells means that males are able to produce spermatoza for the entirety of their life after puberty. Quite a key difference between the process of spermatogenesis and oogenesis. Anyway, I hope that makes perfect sense for you. Good luck.